Right, second subtopic, which is on energy and conservation of energy. So in this subtopic, you have to be able to define and use gravitational potential energy, elastic potential energy of a spring, and lastly, kinetic energy. And you have to also be able to state what is the principle of conservation of energy, apply the principle of conservation of mechanical energy, and lastly, state and apply work energy theorem. Okay. So firstly, what is energy? Energy is defined as the system's ability to do work. Okay. So maksudnya kalau kita ada ability untuk buat lagi banyak lah. Maksudnya lagi besarlah energy yang kita ada. Gitulah. Okay. Energy ni pula, it is a scalar quantity. It has the unit of joule, which is J. There are two types, which is potential and kinetic energy. I think time SPM kamu sudah belajar juga pasal ni benda. So potential energy is the symbol is U. So it is the energy stored in a body or system due to its position, shape ataupun state. And state bukan atau. Okay? So potential energy ni pula, there are two types of potential energy. Firstly, we have the gravitational potential energy. Second one is the elastic potential energy. So gravitational potential energy, it is the energy stored in a body ataupun system due to its position. Okay, so the the other one, which is the elastic potential energy, it is the energy stored in elastic materials. Okay, it is the energy due to the result of their stretching and compressing lah. Okay, so gravitational potential energy, the symbol is U, the formula is equal to mgh. So based on this alone, we can say that the gravitational potential energy will be higher ataupun will be bigger when the height is higher. Macam itulah. Okay, so m is the mass of a body, G is the acceleration due to gravity, which is 9.81 meter per second square, and h is the height of a body from the initial position. So please make sure you know it is from the initial position. Next, we have the elastic potential energy. So the formula is equal to half kx square, ataupun we can say it is equal to fx, because the force di sini ni is equal to kx untuk spring. Okay, make sure kamu letak s di hujung because that defines that it is the elastic potential energy. K is the spring constant, it is given in the question. X is the value of compression ataupun extension of the spring. Lastly, F is the applied force. Right, so now let's look at the graph dulu. Force extension graph. Okay, we know that spring is a device that we can stretch, compress, and then because of the ability, it can then store what we call elastic potential energy. Okay, so when we compress ataupun stretch, it releases the spring, and then ataupun releases the spring, we are actually transforming this potential energy into kinetic energy. Okay, so basically apa yang kita buat ni, bila kita compress ataupun bila kita stretch dia, we are transforming from potential energy, I'm just gonna put U lah. Okay, so from potential energy, it is converting into kinetic energy. Okay, remember kinetic energy ni bila something moves. Kalau kita stretch kan, bila kita lepaskan, dia terus bergerakan. So maksudnya dia ada the presence of kinetic energy. Okay, so Hooke's law pula, if you remember Hooke's law, I think you have learned it during SPM if I'm not mistaken. So Hooke's law pula, it states that the restoring force, which is Fs of a spring, is directly proportional to the amount of stretch of their stretching ataupun compressing. Okay, so mathematically we can write that as negative kx. This is the force, nilai force yang required untuk kita compress ataupun untuk kita stretch a spring. So what is the negative sign here? Negative sign is telling us the direction of the restoring force, which is always opposite to the direction of the amount of stretching ataupun compressing. Kenapa negative? Sebab spring ni, bila kamu tarik dia, dia akan ada tendency untuk let go. Maksudnya dia akan ada tendency untuk go back to its normal. That's why dia punya direction tu mestilah opposite. Sebab dia tidak mau stay on the position that you are making it doing. Unless dia back to equilibrium, yalah, tidak lah. Tapi sekarang ni kalau kamu stretch atau compress, dia akan sentiasa want to go back to its normal state. Gitulah. Okay, that is the meaning of each of this. So for calculation, remember to ignore the negative and use just F as equal to kx. So the unit is kilogram second square. Per second square, sorry. So from the Hooke's law, without the negative sign, restoring force against an extraction of the spring can be, a graph there can be drawn like this lah. Okay? So the work done to stretch a spring to a distance x, we can calculate the work under the graph. The work done is gonna be equal to area under the graph of F against x. Okay, and then we know from that we can then conclude that work done is equal to work done is equal to half kx square, which is equal to the elastic potential energy. Okay? Right, so macam ni lah. Sekarang ni kalau kita force ni, we are trying to take this spring, we are trying to stretch this spring to a distance x. So the restoring force is trying to restore to its original position. Itulah, macam itulah. Okay? So macam juga kalau at equilibrium, tidaklah ba? Semua dua-dua ni akan equal to 0. This is your equilibrium position lah. And then untuk bila this spring is compressed, the restoring force will be trying to bring it to its original position in the opposite direction. So that's why the restoring force will be negative bila the force is positive. Macam tu. Okay? Alright. Next, we are going to learn about kinetic energy. So what is kinetic energy? Kinetic energy is the energy of a body due to its motion. Okay? So kalau ada motion, there will be a presence of kinetic energy. So the maths from this is K equal to half mv square. So K is the kinetic energy, m is the mass of the body, and v is the speed of the body. Okay? So principle of conservation of energy is... So what is the principle of conservation of energy? It states that in an isolated system, the total energy of that system is always going to be constant. Okay? So the energy is conserved in the closed system. So mathematically, it can be written as shown here, here, and then it can be transferred from one form to another. But remember, energy cannot be destroyed ataupun created. Okay? So actually, I don't really get what do you mean by creating the energy? Okay, so it is not created. It is what? Presence? Begitu lah. Macam itulah. Okay, so next we are going to learn about principle of mechanical energy. So it states that in a conservative system where the system has no friction, the total mechanical energy, kinetic plus potential, is always constant. So mathematically it is written this way. So conservative system means only conservative forces such as gravitational and elastic forces are acting on the system. Okay, what else do I need to show? Do I need to talk about? Oh, okay, so now. Okay, so let's look at this situation. So both blocks have the same mass and same speed, different directions of motion. Okay, so sekarang ni, remember kinetic energy, it depends on both mass and velocity. So bila both object has the same value, has the same magnitude, sama ke tidak kinetic energy? Mestilah sama, sebab kinetic energy bukan depends on direction, it depends on the magnitude of mass and velocity. So akan sama. Sekarang ni pula, this block is the same as the previous, but then the second block has twice the mass and twice the speed. Okay? Same speed. So, sekarang ni apa jadi dengan kinetic energy? Still, mass ni akan double V square. Mestilah the kinetic energy will be double from the red block lah. Okay? Sekarang ni kita tengok pula. Dia ada same mass, twice the speed. Twice the speed. Sekarang ni, bila kita letak twice the speed, sekarang ni tadi previously macam ni. Tapi sekarang the second block is twice the speed. Sekarang ni ada square. So, kiranya dia akan jadi half m 4v square. So, berapa kali ni? Dia akan 4 times greater lah. So, that's why what this diagram is telling you is kinetic energy depends on both mass and speed lah. Okay? So, bila the speed is greater, the kinetic energy will be greater. Okay? Walaupun kalau the same mass saja, usually they double je lah. If you double up the mass, usually the kinetic energy will be twice. Tapi kalau kau double, if the mass is constant, double the speed, the kinetic energy will be 4 times greater. Gitu. Alright. Let's look at this one pula. Okay, so if you were to throw a rock from this height, at this position, you will only have potential energy, okay? Because this is the position where the gravity is trying to make the stone go down. Begitulah. So, dia ada tarikan gravity only. So, from this point, there is only a presence of potential energy. So, this is our initial position. Sekarang ni, bila kamu di half of this, dia akan ada both half potential energy and half of it is kinetic energy. Kenapa ada presence of kinetic energy? Sebab sekarang ni dia ada nilai V. Tapi di sini pula dia ada nilai V. It is at rest. Then at this point pula, it is going back to the ground. So sekarang ni dia tidak akan jatuh lagi ke bawah. So that's why we are saying that this is all kinetic energy. Okay? Right, sama juga untuk gun. We have only potential energy at this point. Okay? Tapi bila kamu shoot it out, there is only a presence of kinetic energy. Sebab sekarang ni dia ada velocity. Okay? Okay, what else? This one pula. Okay, so initially the pebble is here, so there is no motion. It is equal to 0. So, kejap. Dia bilang 0. Oh, okay. So, this is the gravitational potential energy. It is equal to 0. So, dia ada kinetic energy saja. And then at this point, the pebble loses its kinetic energy. So, it gains potential energy because it will be going down. So, the gravity is pulling it down. At this point, kinetic energy is equal to 0. Sebab at maximum height, final velocity is equal to 0. And then, as it falls down, the pebble loses its potential energy and gains kinetic energy, because at this point, just now tadi ni the pebble would have the same as the potential energy because it is going up from its initial position lah. Okay? What am I saying? It's okay. Nanti kita belajar balik di kelas. Okay, so as it falls, the pebble loses its potential energy and gains kinetic energy. So the pebble speed up. Yeah, bukan speed up lah. There's a magnitude of velocity causing it to go down, and then at this point here where it goes back to its initial position, the gravitational potential energy will be equal to 0. Okay? So in real situation where friction acts on the system in a direction opposite the direction of motion, the initial mechanical energy of the system equals to the reduced final mechanical energy of the system plus the heat energy due to work done by friction lah. Okay, so sekarang ni kita punya, bila ada presence of friction, kamu akan guna this formula. Okay? Alright. Let's look at the work energy theorem. So what is work energy theorem? It states that the work done by the net force on a body will equal to the change in the body's kinetic energy. So the formula is W equal to delta K equal to K final minus K initial equal to half mv square minus half mu square. So if we simplify that, you will get it will equal to half m v minus u square. Gitu lah kan. Yeah, should be like this. Ataupun kamu mau tulis delta v square? No, that doesn't look right. I think last time we write it this way. Yeah, betul lah. Okay, so when the work is positive, kinetic energy will increase, i.e. the final kinetic energy will be greater than the initial kinetic energy. So the particle is moving faster at the end of the displacement lah. So when work is negative pula, which is this one, the kinetic energy is decreasing and the speed is less after the displacement. When work is 0, the kinetic energy will stay the same and the speed is unchanged. Oh, ni ba? Usually student will write work equal to delta K. Itu work energy theorem. Yang ini apa ya? Kamu tahu juga apa the equation, right? What is the formula for kinetic energy? Okay, now finally masuk example. So let's look at example number 3. A force of magnitude 800 Newton causes an extension of 20 centimeter on a spring. We have to determine the elastic potential energy of the spring when the extension of the spring is 30 centimeter. Extension is equal to x. 30 centimeter is 20.3 meter. Okay, so ada nilai force which is 800 Newton. Extension causes an extension of 20 centimeter. Oh, okay. So F is equal to 800 Newton when X is equal to 20 centimeter. So we have to determine the elastic potential energy, that is US equal to apa so US tu? Oh, okay. Half kx square. Okay. So sekarang ni X yang kita mau cari is X. Si label macam tu lah. Yang X yang kita mau cari is X. No. Okay. Elastic potential energy yang kita mau cari is when extension is equal to 0.3 meter. Tapi sekarang ni kita ada nilai force when the extension is equal to 0.2 meter saja. Okay. So sekarang ni kita perlu cari nilai K. K ni kita tiada. So how do we do that is by using F equal to Kx. Okay, so K is a constant. Dia akan constant. Kiranya apa-apa variable pun, nilai K ni akan sentiasa sama untuk apa-apa situation pun. Okay, so K is equal to F1 over X1. So F is equal to 800 Newton over the extension which is 0.2 meter. So dapatlah nilai 4 times 10 to the power of 3 Newton per meter. Okay, so that is your spring constant. So that is gonna be half 4 times 10 to the power of 3.3 square equal to, dapatlah dapatlah the elastic potential energy which is 180 joule. Okay. Question B pula, a mass of 60 kg is suspended vertically from the spring. So this is the thing. Then this is our spring. This is the spring. And then ada object at the bottom here. Okay, so when a spring is attached to something heavy, it would obviously cause the spring to expand lah kan. Macam mana mau lukis expand ni? X will stretch lah kiranya. Okay. Gitulah. Okay. So that value of extension which is awal-awal dia tiada objek lah. So after kena hook with something, this is the value of how much the spring has extended lah. So this is our nilai. This is our value of X. Okay? Okay. Lepas tu kita perlu buat apa pula? Kita perlu cari elastic potential energy lah. Kan? Yalah. Kita perlu cari the value of X dulu. Sebab untuk kita cari the elastic potential energy, kita perlu ada value of X. So macam mana kita cari value of X ni sekarang? Kita boleh guna the formula F equal to Kx square. Kan? Nilai K ni macam mana pula? Nilai K ni mestilah sama dengan yang kita cari di atas, which is this one. Kenapa sama? Sebab the spring that we are talking about is the same for both A and B. Okay, so sekarang force apa pula yang ada di spring yang ini? So the forces that is present in this situation is, of course, the weight. Okay? And then dia akan ada di restoring force lah. Remember, kita ada restoring force, which is in the opposite direction lah. So this is our restoring force. This is our weight. Sekarang ni, kan? Okay? So sekarang ni, what is the value of F net sekarang? Okay? So we have to find the net force acting on this, in this situation here. So sekarang ni, dia tidak akan stretch di bawah lagi. Dia akan equal to 0 sudah. Sebab sekarang ni itu maximum stretch yang dia boleh bila kena gantung 60 kilo. Bila kena gantung that block to spring tu, dia stretch sampai situ sajalah. Okay, so kita boleh letak dia in equilibrium suatu time tu. Bukanlah in equilibrium, what do you mean? Bukan in equilibrium, no, not in equilibrium. Itu je nilai maximum stretch dia boleh extend bila block 60 kg ni kena gantung. Begitulah. Okay, so net force is Fs minus mg equal to 0. Okay, so that is, oh actually kita guna ni lah, sorry. So kita akan guna net force lah. So Fs is apa? Kx equal to mg lah. So K is equal to mg over x. So m is 60 kg. 9.81 divided by x, which is bukan K lah kita cari x. Okay, so x is equal to mg over K. So x is equal to 69.81 divided by 4 times 10 to the power of 3. So x is equal to 0.147 meter. Okay, so substitute sajalah over here. That is square. So the elastic potential energy is equal to 43.2 joule. Okay. Next, we are gonna do example number 4. So for example number 4, in a smooth pulley system, a force F is required to bring an object of mass 5 kg to the height of 20 meter at a constant speed of 3 meter per second. So we have to determine the value of force and the work done by the force. Okay, so what you need to do first if you come across a question, macam mana? Biasakan diri untuk draw the free body diagram lah. Okay, I think the free body diagram really help you in solving the question lah, sebab saya rasa it's easier to see what you need to determine lah, begitu. Okay, so sekarang ni sekarang ni objek ni bergerak ke atas. So dia suruh cari the work done. Dia suruh cari the force F as well as the work done by the force. So kiranya dari di sini, dari the block 20 meter, dia akan bergerak lagi tinggi lah kan. Dia akan ke situ. So that displacement, this displacement is here. So that is your value of S lah. Okay. So what is present? First is the weight and then we have the tension lah. So that is mg and then tension. Tension is the force lah. Kamu boleh, oh yalah, kamu boleh letak just F sebab the force yang di sini ni actually the tension lah. So this is your F lah. Okay. Okay, so how do we find the force sekarang ni? The force, determine the force kan? Dia minta force kan? Oh, okay, so the force ni kita boleh use chapter 3 lah, which is F equal to berapa? Sekarang ni dia bergerak dengan speed yang constant, which is 3 meter per second. So bila speed is constant, we can say that the acceleration is equal to 0. So the total force in the y direction will be equal to 0. Sebab sekarang ni the motion is at a constant speed and we are looking at the y component only. Okay, so that is F minus mg equal to 0. So force is equal to mg. So m is 9.81. So nilai force is equal to 49.1 Newton. And then we have to calculate the work done by the force. That is just F as cos theta. Okay, so that is equal to 49.1. S berapa tadi dia bagi? Dia bagi S is to the height of 20 meters. Huh? S is equal to 20 lah, kan? Oh, kejap. Kenapa dia letak 20 meter di situ? Kiranya dia dari ground lah pergi atas kan maksud dia. Ya, betul lah. So S is just 20 meter lah aduh. This is your value of S. So 20. So your displacement is pointing up here. Your force is in the same direction. So berapa tu? Dia akan cos equal cos berapa? Cos 0 lah sebab this has same arrowhead, same direction. So cos 0. Dapatlah 982 joule. Yeah, okay. So that is the solution for example number 4 and that is the end of our subtopic number 2.